Hello everybody, welcome to YouTube channel Enriched Biology. Today we will do the anatomy of stem, dicostem as well as monocostem. If you cut the transverse section of the dicostem and see it under the microscope, you can say you may cut the section of sunflower, you may cut the section of mustard stem, and the following layers will be visible. The outermost layer is of closely packed cells which form the epidermis. Epidermis bears it may bear. In some cases, there are hair are present. In some other cases, they are not present. So these hair they are multicellular, and in root the root hair were unicellular. In case of stem, the hair are multicellular and they are called as the trichomes. They are called as the trichome. Epidermis is protective in function, and it may be also covered by the layer of cuticle, which also provide additional protection. Then below the epidermis is present cortex. Cortex is differentiated in three layers. Outermost layer is of collochimatous cells. 2 to 3 layers of collochimatous cells are present, which are unevenly thickened, which is called as the hypodermis. It provides mechanical strength to the plant. It provides elasticity to the plant organ. And below the epidermis, many layers of parenchyma cells are present from the cortex, and innermost layer of the cortex is again differentiated into compactly arranged barrel-shaped cells which form the endodermis. Endodermis encloses the stele. What is stele? To say vascular bundles along with its layer, they are called as the stele. So in the vascular bundles, they are arranged. Yes, they are arranged in a ring, and sclerenchymatous to say pericycle is present around each bundle. It is somewhat linear shape. This is the pericycle, and these bundles they are present in a ring. In this case, phloem and the xylem, they are present at the same radius. They are present at the same level. Phloem and xylem, they are present at the same level. So such type of bundle, they are called as the conjoint. They are called as the conjoint. In between the phloem and the xylem, there are present meristematic cells which form the cambium. And such bundles which are present on the same radius, xylem and phloem present on the same radius, they are called as the conjoint collateral. And having the cambium strip in between the xylem and the phloem, the bundles are called as the open bundle, which help in the secondary growth of the stem. In between these bundles, there are present parenchymatous cells, which form the medullary rays. In the center, again, the parenchymatous cells are present, which form the pith of the stem. So this is all about the anatomy of dicot stem. And what about anatomy of monocot stem? It is very much similar to the dicot stem. The different outermost layer is epidermis. Then next layer is hypodermis. Hypodermis in this case is sclerenchymatous. And then it encloses the large mass of green cell, that is ground tissue. In the, or you can say cortex, the vascular bundles, they are not arranged in a ring. They are scattered throughout the cortex. They are scattered throughout the ground tissue. And the vascular bundles, their number is numerous. The condition is polyarch. And they are conjoint, collateral, but they are closed. What does it mean? Closed means xylem and the phloem, they are present at the same level, but no cambium, no meristematic cell, no meristematic tissue is present in between the xylem and the phloem. So there is no secondary growth. So in case of monocot stem, bundles are conjoint, collateral and closed. And in both of the cases, in monocot as well as the dicot stem, yes, the bundles are endark. First formed elements, that is protoxylem, they face toward the pith, they face toward the center, and later formed elements of the xylem, which is called as metaxylem, they face toward the pericycle. So this is all about the monocote stem. In this case, what happened? Each bundle, in case of monostem, each muscular bundle is surrounded by scleral chimatous cell, which is called as the bundle sheath. It is called as bundle sheath. So this is all about to say anatomy of monocote as well as the dicot stem. Now we see how secondary growth takes place. So if you take one part of this section, so what you will see, epidermis bearing a trichome, then dicot stem, hypodermis, then cortex, then endodermis, then pericycle, patch of pericycle, below phloem, then metaxylem, then protoxylem. And in between they are present medullary rays. Between the xylem and the phloem there is present cambium. In the center there is pith. So how secondary growth take place? What happened? The pericycle, the cambium which is present in with the xylem and the phloem. This is the cambium. It becomes active. This cambium is called as the intrafascicular cambium, that is present in the same bundle, in the bundle that is in between the xylem and the phloem. The cambium becomes active and it starts dividing and redividing. In addition to this, the cambium of the medullary, the cells of the medullary rays in between the bundles, they go de-differentiated and a small cambial strip is formed. To say, you can say here, in between these bundles, this is the intrafascicular cambium. These medullary rays cells, they again get de-differentiated and form the small cambial strips. These cambial strips, they are connected with the intrafascicular cambial strip and a ring of cambium is formed. So the cambium which was present initially in between the xylem and the phloem, it is the intrafascicular cambium and it is a primary meristematic tissue. The cambium which is formed by the de-differentiation of the cells of the medullary rays in between the bundles, that is called as the interfascicular cambium. Interfascicular cambium, small rings are formed, strips are formed, they unite with the intrafascicular cambium, so a ring of cambium is formed. Ring of cambium is formed. This interfascicular cambium is secondary meristematic tissue. Both are lateral meristematic, but they are secondary meristematic tissue. Then this ring of cambium, it divides and redivides. It adds phloem, secondary phloem towards the outside and secondary xylem towards the inside. So phloem is primary phloem and primary xylem, they are pushed upwards, they are pushed outwards. Secondary xylem is added towards the inner side and secondary phloem towards the outside. So what happens? The primary phloem get obliterated. The secondary xylem form, the elements of secondary xylem, they are much more than that of the secondary phloem. So they form the mass of wood. And primary phloem gets obliterated. However, primary xylem remains intact. So in this way, secondary growth, by addition of these cells, the girth of the plant, girth of the stem will be added. It will be increased. So in this case, in this way, the secondary growth take place. The wood which is formed by the elements which are formed by the secondary growth, they are called as the wood. You can say then depending upon the time of the environment, these cambial cells, they are more active during spring and they are less active during the winter season, during the autumn season. So when the cambium becomes active during the spring season, much more elements are added. They divide and re-divide enormously and large wood is formed, and such wood is called as the spring wood. And in this case, in the spring wood, the xylem elements, the vessels, they are larger. And in case of autumn season, in case of winter season, cambial strip no doubt becomes active, but the speed of division is somewhat lesser. So smaller elements are added, and such wood is called as the autumn wood. Such wood is called as the autumn wood. So when the cambium divide, the ring of phloem and xylem is added in one season. First, you can say in the spring season, one ring of xylem will be added. In the next, phloem will be added. In the autumn season, again small ring of xylem and phloem will be added. In next year, again large ring of xylem and phloem will be added, and then a small ring of xylem and phloem will be added. So rings are formed in the tree. And such rings they are called as the annual rings. They are called as the annual ring. By counting the rings, number of the rings, we can know the age of the plant. We can know the age of the plant. So how annual rings are formed? They are formed by the secondary wood, which is formed with spring wood as well as the autumn wood. In the by the activity of the cambium in the spring season, followed by activity of the cambium in the autumn season, and these rings they collectively, autumn ring and spring ring, they are called as the annual rings, and they are formed simultaneously in next year as well. Then there is sapwood and heartwood. What is heartwood? What is sapwood? When the cambium becomes active, the addition of xylem elements is much more than the phloem, and much more elements they are added towards inside, and they become the elements which are older, they become to say lignified, tannin, resins, they are deposited in these elements, and it becomes dark in color. It is called as the heartwood. And the elements which are added later on, they are soft in nature. They are added towards the outside xylem elements. They are somewhat soft. That is called as the sapwood. Heartwood, and heartwood is darker. It is loaded with the many substances, resin, suberin, lignin, etc. And it also it does not harm to say help in conduction of water. However, sapwood it help in conduction of water and minerals. Then this is all about heartwood and sapwood, autumn wood and spring wood. Then is dark wood and light wood, where the inner elements they are added and subrized, lignified, and many elements they are added, substances are added, many antibacterial substances are added, and that wood becomes the dark wood, that becomes dark in color, and the outer wood somewhat is lighter in color. So this is all about secondary growth. Then in the stem, in the vascular bundle, secondary growth by means of vascular cambium. When this xylem increases in size, and it will exert pressure toward the outside. So epidermis as well as some cortex cells will be broken. When much more xylem wood is added inside, epidermis and cortex will be broken, and there is necessity to protect the inner cells. So some of the cells of the cortex, they got differentiated and form the cambium. They divide and divide to form the cork cells. These cork cells, they are deposited, pushed toward the outside. They are lignified. They also contain tannin and somewhat. They become hard and they form the bark of the plant. So you might have seen trees, उनके ऊपर बार बारी लकड़ी कितनी hard होती है, नजर आती हैं वो. That is the bark, and that bark is formed by the cork cell. So when cork cambium cortex cells, they get differentiated into the cambium. They differentiated into meristematic cells. That cambium is called as the phallogen. This phallogen, it adds some to say cells towards inside as well as outside. And these dermal cells and as well as the cock and phallogen, the cells which are added, they are called as the phalloderm. Phalloderm and phallogen together, they are called as the periderm. So the plant, girth of the plant is added by the vascular cambium, and protection is provided by the core cambium. It also added the girth of the plant. I hope you might have followed. Have a good day. Don't forget to subscribe my channel, like my channel, and share with your friends. Okay, bye.